Okay, welcome back everyone. And in this video, we'll be looking at a solution for creating a DFA M such that this machine accepts the language L, where L is the set of strings over the alphabet 0, 1, where, and this is actually one of the most complicated conditions we've seen so far, the number of zeros plus 2 times the number of ones, right? Of course, I'm using a shorthand, but I mean of W, modulo 5, okay? So modulo 5 is what's the remainder of the division of this guy by 5, right? So modulo 5 gives you the remainder, right? And the condition is that I want this sum mod 5 to be less than 1. So really, actually, I can rewrite this because if I have an integer n and I modulo 5 it, then I can either have 0, 1, 2, 3, or 4, right? This is an equivalence relation, okay? Because if I have any other integer, it's going to be either in this equivalence class, this equivalence class, this one, or this one, okay? So that means if I want the modulo to be strictly less than 1, then the only way that this can happen, okay, is of course if the modulo 5 is equal to 0. And actually here I'm going to be even more precise. So you might have seen this in a number theory course. If you haven't, or a discrete math course, I'm going to write congruent to 0, okay? And this congruence just means that I'm saying that it's going to belong to the equivalence class of 0 mod 5. Okay, so really I should be writing 0 mod 5. Okay, so what's the idea here? Because this is actually quite a complicated expression, right? But really the states, right? The states don't actually care about this operation, this function. They only care about encoding some piece of information. And so what will my states encode? Well, actually, what can my states encode? That's useful to this, to creating a machine that accepts this language. Well, when you think about it, if you know that modulo 5 only has these 5 options, the natural thing to say is, well, each state could represent a modulo, right? So maybe this one could be 0 mod 5. This one could be 1 mod 5. This can be 2 mod 5. You'll notice my states have gotten bigger because I realized that I need more space to write this. And this could be 4 mod 5, right? And, okay, first of all, I think, so my claim is that I'm quite sure that this is going to sort of encapsulate all of the information I need to accept such a language. I feel like this is a natural initial conclusion because all the information that you really need here is this modulo 5 piece of information, right? And then the next thing is, okay, so I have these 5 states. They each represent a different modulo. Now, where's the start state going to be, right? So where's the start state? Well, always ask yourself for the start state, what state encodes the information I have when I haven't read anything, right? So imagine you have some string W, but your pointer is pointing right before, right? So actually you've seen nothing yet. If you've seen nothing yet, that means that the number of zeros is 0, the number of ones is 0. So then if I plug that into my formula, right, so if I have this mod 5, then this is going to be equal to 0 plus 2 times 1 mod 5, 2 times 0 mod 5. So 0 plus 2 times 0 is 0, so then I get 0 mod 5. So that means that this should be my start state. Okay, now there's only two, there's really, for each state, right? So for each state here, we know that there are only two things that can happen, right? So either you read a 1 or a 0, right? So if you have n0, so let's just represent this abstractly. If you have n0 plus 2n1 mod 5, right? And you read a 1, right? So then in your new setup, you're going to have the number of zeros, let's call them the new number of zeros, let's call them the number of zeros prime, is going to be the number of zeros plus 1, right? The initial number of zeros plus 1. So this implies that you're going to transition to n0 prime plus 2n plus 1 mod 5, right? You're going to end up in the state that's represented by this modulo, right? But I know that this is n0 plus 2n1, right? n0 plus 2n1 plus 1 mod 5. So what this is telling me is if I read a 1, I just go up 1 modulo, okay? So if I'm in this state and I read a 1, then I go from 0 mod 5 to 1 mod 5. If I read another one, I go to 2 mod 5. If I read another one, I go to 3 mod 5. If I read another one, I go to 4 mod 5. And then if I read another one, right, then I get 5 modulo 5. But 5 modulo 5 is asking you, what's the remainder of 5 divided by 5? Well, that's 0, right? So then you go back to the initial start state, right? So then the transitions will look like this. Okay? So those will be the transitions for my number of zeros. For my number of zeros. Okay, so that's the number of zeros. We can obviously test it out, right? So I realize I'm running out of room to test it out. So maybe let me copy this whole machine onto the next page. Let's do that. Okay, let's copy this. Let's put it here. Excellent. Okay, so what if I have W is 0, 0, 0, right? Well, the number of zeros in W is 3. The number of ones in W is 0. So I have 3 plus 2 times 0, right? From M0 plus 2 times N1. And then mod 5, right? So mod 5. Then that's 3 mod 5, right? And so where I should end up I should end up in the state 3 mod 5, right? So I should be 1, 0, another 0, and another 0. And yes, indeed, I'm in 3 mod 5. Okay, now what can happen if instead of reading a 0, right, I read a 1, right? So the 1 is slightly different because it changes the modulo not by 1, right? You're multiplying n1 by 2. So you have to be a bit more careful here, right? So suppose, again, where do I want to do this? Okay, I'm going to erase this just so we don't confuse each other. So that was for, right, the number of zeros. Now the number of ones. So suppose I have some string W that I've read, right? That string W has n0 plus 2n1 mod 5. It's in this state, right? Now suppose I read an additional 1, right? So I'm in W1. W1 concat 1, sorry. So then the number of ones in this string, let's call it n1 prime, is n1 plus 1, right? So then where I should go to the state n0 plus 2 n1 prime modulo 5. Okay, but what is this? This is just n0 plus 2 times, and now I just plug in the n1 prime, right? n1 plus 1, right? Because I know that n1 prime is n1 plus 1. Because what I've just said that I'm adding a 1 to the W, right? Mod 5. And so then what I get is n0 plus 2 n1 plus 2 mod 5. So what does this mean? This means that if I'm in some state, I'm actually going to transition not one, but twice, right? Right? Because that means that if, for example, if initially I was in 1 mod 5, if I read another one, then this is telling me that I'll go into 1 plus 2 mod 5. So 3 mod 5, right? So that means that if I'm in 1 mod 5 and I read a 1, then I'm going to go to 3 mod 5. And actually, I should have started with 0, right? 0 is probably the clearest one. If I have, suppose my string is empty, and then I read a 1, then 2, so then I'll have 0 plus 2 times 1, right? Because I just read my first one. So that's 2, so then I have 2 mod 5, right? Sorry, I keep writing my 5 like this. Mod 5, okay? So then from 0 mod 5, if I read a 1, I go to 2 mod 5. Then from 2 mod 5, if I read a 1, I go to 4 mod 5. Right? Is that right? Yes. Okay. Then for 3, right? So if I have 3 mod 5, now I need to be careful. If I read another 1, then I go from 3 mod 5 to 3 plus 2 mod 5. Which is 5 mod 5, right? So this is asking, what's the remainder when I divide 5 by 5? Well, the remainder is 0, right? And again, because of equivalence classes, mod 5. And here I'm skipping notation, right? But I should be writing congruent. So if you're from a mathematical background, then please forgive me. And if you're not, then just remember that we're dealing with equivalence classes, so really proper notation should always be used, but I'm cutting corners here just to sort of illustrate my point. Right, so from 3 mod 5, I should go to 0 mod 5. So I should go here. And then finally from 4 mod 5, right, so if I have 4, but then I add 2 mod 5, then I should get 6 mod 5. So if I divide 6 divided by 5, the remainder, right, the remainder of this, so I should have asked the remainder of 6 over 5 is 1, right? So really this is 1 mod 5. And so from 4 mod 5, if I read a 1, I should go here. Right? Whoops, let's try not to confuse the transitions. Okay, great. And so you'll notice that this is definitely a valid DFA, right? For each state, I have 2 outgoing transitions. Each of these outgoing transitions for a state are for different symbols on my alphabet because I've assumed that my alphabet is 0, 1. So all that's left to do is the final state. Well, the final state is easy, right? Once I've done all this work, I know that all I care about is if this guy, mod 5, is 0. And so the final state that I'll pick is this guy. So then this guy is the final state, and this machine, M, is a machine, or the DFA M, such that the language accepted by M is L. And I'm happy. Great. So this concludes the exercise solution for this question.